Johannes Kepler, discovering the secrets of the planets. Learn English through story. Have you ever looked up at the night sky and wondered why the planets move the way they do? For thousands of years, people believed they already knew the answer. Kings, philosophers, and even the greatest scholars were convinced that the heavens were perfect. They believed the planets traveled around the Earth in flawless circles, following a pattern that could never be questioned. But what if that belief was completely wrong? What if one quiet man, armed with nothing more than curiosity, mathematics, and endless determination, could change humanity's understanding of the universe forever? This is the incredible true story of Johannes Kepler, the brilliant scientist who unlocked the hidden secrets of the planets. His discoveries became the foundation of modern astronomy, inspired Isaac Newton, and made today's space missions possible. Yet his journey began far from the grand observatories of Europe. It began with a sickly little boy who was never expected to accomplish anything extraordinary. Johannes Kepler was born on December 27, 1571, in the small German town of Wilderstadt. From the day he entered the world, life challenged him. He was born prematurely, and his body was weak. As a young child, he caught smallpox, a terrible disease that nearly took his life. Although he survived, it left him with poor eyesight and hands that were permanently damaged. Most people assumed such a fragile child would live an ordinary life. But they could not see what was happening inside his mind. Johannes possessed an imagination that seemed as vast as the sky itself. When evening arrived, he loved standing outside with his mother, looking up at the stars. She told him stories about the heavens, pointing to bright constellations that had fascinated people for centuries. One night, when Johannes was only 6 years old, a brilliant comet stretched across the sky like a glowing ribbon. He could not look away. A few years later, he witnessed a total lunar eclipse. As Earth's shadow slowly covered the moon, he felt something he had never experienced before. Wonder. Questions filled his mind. Why did these events happen? Who decided where the planets should travel? Could the universe really be understood? Those questions would stay with him for the rest of his life. Life at home, however, was far from peaceful. His family struggled with poverty. His father worked as a soldier and often disappeared for long periods. One day, he left and never returned. Johannes' mother worked tirelessly to care for the family, but money was always scarce. Despite these hardships, Johannes discovered something no one could ever take away from him: learning. His teachers quickly realized he had an extraordinary talent for mathematics. Numbers seemed to make perfect sense to him. While other students memorized lessons, Johannes searched for patterns hidden beneath every problem. Scholarships allowed him to continue his education when many children from poor families had no choice but to leave school forever. He understood how fortunate he was. Every opportunity became another step toward his dream. Eventually, Johannes entered the University of Tübingen, one of Germany's finest universities. There he studied mathematics, astronomy, philosophy, and theology. Most students accepted the traditional view that Earth stood motionless at the center of the universe. It had been taught for nearly 2,000 years. Questioning it seemed almost impossible. Then one of his professors introduced the class to an extraordinary idea proposed by Nicolaus Copernicus. According to Copernicus, the sun, not the Earth, stood at the center of the planetary system. Many students laughed. Some dismissed the theory without even considering it. Others feared supporting such an idea because it challenged long-held beliefs. Johannes reacted differently. The more he studied the theory, the more logical it became. The strange movements of the planets suddenly appeared much easier to explain. Deep inside, he became convinced that Copernicus was right. He did not know it yet, but that decision would shape the rest of his life. After graduating, Johannes accepted a position as a mathematics teacher in Graz, Austria. He taught students during the day, prepared calendars, and made astronomical predictions to earn a living. But every evening, after his work was finished, he returned to the question that refused to leave his mind. Why did the planets move the way they did? He filled notebooks with calculations. He drew diagrams. He compared distances. He searched endlessly for mathematical patterns hidden among the stars. Sometimes he worked until sunrise. His small room became covered with papers, books, rulers, and handwritten equations. Friends wondered why he pushed himself so hard. Johannes would simply smile. He believed the universe was speaking through mathematics. Someone only had to learn how to listen. One day, while studying the known planets, another mystery captured his attention. Why were there exactly 6 known planets? Why were they arranged at those particular distances from the Sun? Surely it could not be an accident. Kepler believed the universe reflected a beautiful mathematical design. Every planet, every orbit, every movement, everything had to fit together like pieces of a magnificent puzzle. For years, he searched for the hidden harmony connecting the heavens. Sometimes he believed he was close. Then a single calculation would destroy months of work. Still, he refused to give up. Failure did not discourage him. It simply meant the universe was asking him to look more carefully. Then, in the year 1600, an unexpected invitation arrived. It came from the greatest astronomer in Europe. His name was Tycho Brahe. Tycho had spent decades observing the night sky with astonishing precision. Long before telescopes existed, he had measured the positions of planets more accurately than anyone else in history. His records were priceless. Johannes immediately understood what they meant. If there was a hidden mathematical law governing the planets, Tycho's observations might finally reveal it. Without hesitation, Kepler packed his belongings and traveled to Prague. He believed he was about to begin the greatest adventure of his life. He had no idea that the discoveries waiting for him would eventually change the course of science forever. Johannes arrived in Prague with excitement and hope, believing that he was about to unlock the greatest mystery of the universe. The city was alive with scholars, artists, and scientists, but no one fascinated him more than the legendary astronomer Tycho Brahe. Tycho was unlike anyone Johannes had ever met. He was wealthy, confident, and famous throughout Europe. For more than 30 years, he had devoted his life to observing the heavens. Night after night, regardless of freezing winters or stormy skies, he carefully measured the positions of the planets using enormous astronomical instruments. Since the telescope had not yet been invented, every observation required incredible patience and precision. His records were the most accurate the world had ever seen. Johannes could hardly believe he was standing beside the man whose work he had admired for years. But working together was not easy. Tycho was proud of his life's work and guarded his precious observations carefully. He worried that other scientists might steal his discoveries before he had the chance to publish them. Johannes, on the other hand, desperately wanted access to the data so he could test his mathematical ideas. Their personalities often clashed. Sometimes they argued for hours. Tycho believed Johannes asked too many questions. Johannes believed Tycho shared too little information. Yet beneath their disagreements was a shared dream. Both men wanted to understand the universe. Then, just as their partnership was beginning to grow stronger, tragedy struck. In the autumn of 1601, Tycho Brahe suddenly became ill. Within days, the greatest astronomer in Europe was dead. Before he died, he entrusted much of his priceless astronomical data to Johannes Kepler. It was an enormous responsibility. Kepler now possessed decades of observations that no other scientist had ever seen. He knew exactly where to begin. Mars. Of all the planets, Mars had always been the most puzzling. Its strange movements across the sky confused astronomers for centuries. Sometimes it appeared to move forward, then backward, before continuing on its path again. The old models could never explain its behavior perfectly. Kepler believed the answer was hidden inside Tycho's measurements. He locked himself away and began calculating. 1 week became 1 month. 1 month became 1 year. Then another. His desk disappeared beneath mountains of paper. He calculated every distance, every angle, every position. Thousands upon thousands of mathematical problems filled his notebooks. His eyes grew tired. His hands ached. Many nights he forgot to eat. Still, he continued. Again and again, his calculations almost matched the observations. Almost. But almost was not enough. The difference was tiny, less than the width of a fingernail held at arm's length, but Kepler refused to ignore it. Many scientists would have adjusted the numbers to fit the accepted theory. Kepler would not. If the observations disagree with the theory, he thought, perhaps the theory is wrong. It was a bold idea. For nearly 2,000 years, scholars believed that circles represented perfection. Surely God would have created perfect circular paths for the planets. But the heavens themselves seemed to disagree. Night after night, Kepler checked every calculation. He searched for mistakes. He started over countless times. Every road led to the same conclusion. Finally, one quiet evening, as candlelight flickered across his papers, the answer appeared. The planets were not moving in circles. They were moving in ellipses. Kepler stared at the page in silence. It was such a simple shape. Yet it explained everything. The strange movements of Mars suddenly made perfect sense. The observations matched the mathematics exactly. For the first time in history, someone truly understood the path of a planet. Johannes smiled, but only for a moment. He immediately began checking his work again. Great discoveries required absolute certainty. Days turned into weeks as he repeated every calculation. The result never changed. He had uncovered one of nature's deepest secrets. The planets travel around the Sun in elliptical orbits, with the Sun located at one focus of each ellipse. This became known as Kepler's first law of planetary motion. The discovery shocked the scientific world. Some scholars admired it. Others refused to believe it. After all, abandoning perfect circles meant abandoning centuries of accepted wisdom. But Kepler trusted evidence more than tradition. He believed nature always tells the truth. His work, however, was far from finished. As he continued studying the planets, another mystery caught his attention. The planets did not move at a constant speed. When Mars approached the Sun, it seemed to race through space. When it moved farther away, it slowed down. Why? Once again, Kepler filled page after page with calculations. Months passed. Then another year. Finally, another beautiful pattern emerged. He discovered that an imaginary line connecting a planet to the Sun sweeps out equal areas in equal amounts of time. Although the mathematics was complex, the idea revealed something extraordinary. The planets speed up when they are close to the Sun and slow down when they are farther away. Nothing about their motion was random. Every movement followed an elegant mathematical rule. This became Kepler's second law of planetary motion. Two impossible mysteries had now been solved. Kepler felt as though he was listening to the heartbeat of the universe itself. Yet while his scientific discoveries were bringing him closer to the stars, life on Earth continued to test him. Europe was becoming increasingly unstable. Religious conflicts spread across the continent. Political tensions grew stronger each year. Disease and hardship touched nearly every family. Kepler's own life was filled with sorrow. Financial problems never seemed to disappear. His health often failed him. Several members of his family became seriously ill. Yet every evening, after facing the struggles of daily life, he returned to his papers and looked once more toward the heavens. The stars became his source of hope. Whenever he felt overwhelmed, he reminded himself that the universe remained beautifully ordered, even when life on Earth seemed uncertain. He believed there was still one final secret waiting to be discovered. A hidden relationship connecting every planet in the solar system. And he was determined to find it, no matter how many years it would take. Little did he know that his greatest discovery was still ahead, a discovery so powerful that it would inspire Isaac Newton, shape modern physics, and guide spacecraft across the solar system centuries later. Years passed, but Johannes Kepler never stopped searching. Many people would have been satisfied after discovering that planets move in elliptical orbits and change their speed as they travel around the Sun. Those discoveries alone would have guaranteed his place in history. But Kepler believed the universe still had one more secret to reveal. Late into the night, while candles flickered beside stacks of worn notebooks, he continued comparing the orbits of every known planet. Mercury, Venus, Earth, Mars, Jupiter, and Saturn all seemed different, yet he felt certain they were connected by one elegant mathematical rule. The calculations were enormous. Without calculators or computers, every equation had to be solved by hand. One small mistake could erase weeks of work. Still, Kepler refused to give up. He often reminded himself that nature never lies. If he followed the evidence with patience, the answer would eventually appear. Then, after years of relentless effort, it finally did. He discovered that the farther a planet is from the Sun, the longer it takes to complete one orbit. More importantly, he proved that this relationship followed a precise mathematical pattern shared by every planet. It was breathtaking in its simplicity. The universe was not random. It was built upon laws that anyone could discover through careful observation and mathematics. This became known as Kepler's third law of planetary motion. With that single discovery, Johannes Kepler completed one of the greatest achievements in the history of science. For the first time, humanity possessed a complete mathematical description of how planets move through space. The heavens were no longer mysterious lights wandering across the night sky. They had become a magnificent cosmic system governed by universal laws. News of Kepler's discoveries slowly spread across Europe. Many scientists were amazed. Others refused to believe him. Accepting Kepler's work meant admitting that ideas accepted for nearly 2,000 years were wrong. History has shown that revolutionary ideas are rarely welcomed at first. Truth often arrives quietly, long before the world is ready to accept it. While Kepler's reputation continued to grow, his personal life became increasingly difficult. His beloved wife, Barbara, became seriously ill and eventually passed away. Several of his children also died at young ages, tragedies that broke his heart. Every loss left deep emotional scars. Many people in his position would have abandoned their work completely. But Kepler found comfort in the stars. Whenever life became unbearable, he returned to his calculations. The orderly movements of the planets reminded him that even in a world filled with suffering, beauty and harmony still existed. Then another crisis struck, one unlike anything he had faced before. His elderly mother, Katharina Kepler, was accused of witchcraft. At that time, fear and superstition ruled many parts of Europe. People blamed illness, bad weather, and unexplained events on supposed witches. Innocent men and women were imprisoned, tortured, and even executed based on little or no evidence. Katharina's life was suddenly in terrible danger. Johannes refused to stand by and watch. For years, he set aside much of his scientific work to defend his mother. He carefully studied legal documents, questioned witnesses, gathered evidence, and prepared logical arguments with the same determination he used to solve astronomical problems. He believed that truth should always defeat fear. His long battle was exhausting, but in the end, justice prevailed. Katharina was released. It was one of the proudest moments of Kepler's life. He had used reason and evidence not only to understand the universe but also to save someone he loved. As the years passed, Kepler continued improving astronomical tables that predicted the positions of the planets with remarkable accuracy. These became known as the Rudolphine tables, named in honor of Emperor Rudolph II. For sailors crossing dangerous oceans, astronomers observing eclipses, and future scientists exploring the heavens, these tables became invaluable. They were the most accurate astronomical charts the world had ever seen. Long after Johannes Kepler's lifetime, another brilliant scientist carefully studied his work. His name was Isaac Newton. Newton realized that Kepler had described how the planets move. Now he wanted to understand why. Using Kepler's laws as the foundation, Newton developed the universal law of gravitation, explaining that the same force pulling an apple toward the ground also keeps the moon, the planets, and the stars in motion. Without Kepler, Newton's discoveries might never have been possible. But Kepler's influence did not end there. Centuries later, engineers preparing humanity's first journeys into space turned once again to his equations. When scientists calculate the path of a satellite orbiting Earth. When engineers send robotic probes to Jupiter and Saturn. When spacecraft travel to Mars. When telescopes circle our planet, capturing breathtaking images of distant galaxies. They all rely on the mathematical principles Johannes Kepler discovered more than 400 years ago. Every mission into space carries a small piece of Kepler's legacy. The little boy who once stood beneath a comet, wondering about the stars, helped humanity reach them. His story is not simply about astronomy. It is about courage. It is about curiosity. It is about refusing to accept easy answers. Johannes Kepler did not possess great wealth. He did not enjoy a life free from hardship. He experienced illness, poverty, war, heartbreak, and personal tragedy. Yet none of those obstacles prevented him from changing the world. He showed us that progress begins with a question. That truth is found through patience. And that the greatest discoveries often belong to those who refuse to stop searching. Today, when you look up at the night sky, the planets continue their silent journey around the sun. They move exactly as Kepler predicted centuries ago. The same elegant laws guide Mercury as it races through its orbit. They guide Saturn as it circles far beyond Earth. They guide distant spacecraft traveling through the darkness of space. The universe has not changed. Only our understanding of it has. And that understanding exists because one determined man chose to trust evidence instead of tradition. Johannes Kepler once wrote that the purpose of science is to think God's thoughts after him, expressing his belief that studying nature was a way to uncover the order built into the universe. Whether viewed through science, philosophy, or simple curiosity, his life carries a timeless lesson. Never stop asking questions. Never fear challenging old ideas when the evidence points somewhere new. And never underestimate the power of one curious mind. Because sometimes, the person who quietly studies the stars ends up changing the future of the entire world. The next time you see the moon shining in the night sky, or watch a rocket launch toward the heavens, or read about a spacecraft exploring another planet, remember Johannes Kepler. The man who discovered the hidden secrets of the planets and helped humanity find its place among the stars. The end.